Our second speaker has been in the feed milling industry for the last 34 years in various capacities as a project engineer, production supervisor, maintenance engineer, production superintendent, plant manager, and national operations manager. As a project engineering manager, he has been involved in the construction of feed mills, poultry, swine farms, slaughter and meat processing plants, fuel service stations, and coal-fired power plants. He is a graduate of mechanical engineering from the University of the Philippines, Diliman, and topped the board licensure examinations in 1987. His advocacy is to help small and medium-sized feed mills improve their operations using appropriate technology. This is one way of giving back to the industry, which has taught him a lot for the past 30 years. Here to talk about controlling the processing parameters for a competitive feed milling operation, let's welcome Engineer Conrado Don Bulanhagi.
Okay, so good afternoon, everyone. I would like to thank you for thank e-agricom for enabling me to this opportunity to share with you some of my experiences, and hopefully it can help you in improving your operations. For this afternoon, my topic would be controlling the processing parameters for a competitive feed milling operation. For the purpose of this webinar, I would define processing in the broadest sense, meaning it will encompass all processes that a feed mill company usually undertakes from the time the sales order is given up to the time the feed is delivered to the doorstep of the store or the farm. So for this seminar, processing would include material acquisition, the shipping and trucking, warehousing and storage, feed manufacturing, and distribution. So in terms of competitiveness, competitive will be defined in terms of total delivered cost as one of the bases. So for the total delivered cost, this would be the sum of the material acquisition costs, plus the shipping and tracking costs, plus the warehousing and storage costs, plus the feed manufacturing cost, plus the distribution cost, and of course the selling cost and the profit margin. I have lined up an estimate of the high, the low, and the average for all these components. This may be not up to date because of the movement of the materials, price movement, and also the fuel. But for purposes of our presentation, I would like to, for example, tackle the material acquisition. So for this one, the high side would be at 22 pesos per kilo. For example, this would be a direct material cost, for example, for the broiler feeds. And the low side would be at 18, and the average would be at 20, for example. So this would be, on average, this will be 57%, make up 57% of the total delivered cost. For the shipping and trucking, for example, I have assumed here a 4 peso high side cost, and then the low at 2 and average 3. Again, this will depend on how far are you from your point of pickup of the raw materials or delivery. Letter C, for the warehousing and storage, I hope also put in 4 as the high side, 2 pesos as the low side, and 3 pesos the average. Again, this will depend on where you are located and the relative rental rates in the warehouse where you are located. Then the feed manufacturing cost, this would be the high of 2 pesos per kilo, low at 1.2, and average of 1.6. Again, depending on whether you are toll manufacturing a certain area or you're producing for your own. Letter E, that's distribution cost. Again, 4 pesos at the high side, 2 pesos at the low, and average of 3. Again, depending on where you are finally delivering your finished fish. So I have rounded up all the numbers for presentation purposes. And then for selling, I just assumed an average of 4.2% selling cost, and for the profit margin, 9% profit for this one. So for the average, For example, the total delivered cost, making up everything, would be at 35.3 pesos per kilo, for example, with a high of 41.6, for example, and low of 29. Again, the range should be very wide depending on where you are located. So how do we define, how do we say if your feed milling operation is competitive? So there are several possible criteria for evaluating your operation. The most common, commonly used criteria would be the feed sales growth is at least tracking the industry or sector growth in whatever sector you're participating, whether you're in poultry, swine, game fowl, ruminant, pet food, or aquatic. So this one is the most commonly used criteria for evaluating if you are competitive. Less commonly used indicators would be number two. Some of your competitors can buy your feeds at total delivered cost and still make a positive margin, no matter how small, especially for this one is somehow true for integrators. In cases where the competitor's feed mill has suffered a major breakdown, sometimes some integrators are buying the competitor's feeds. And if you are the one chosen, then it does not only reflect on your cost, but in your quality also, feed quality. Okay. Another not so commonly used indicator of competitiveness is if you are acting as a toll feed mill for some of your competitors, and your competitors are still making a positive profit or margin, then we can say that your operation is competitive. However, some aspects, let's tackle the cost components one by one. Some aspects, for example, of the material acquisition costs are controllable. Of course, we know that the commodity price itself may be out of the feed miller's control because of worldwide supply and demand interaction. But some aspects of the material acquisition costs can be manageable. For example, quality specifications as you receive it in your plant. As long as the quality is consistent and predictable, the feed mill can still be competitive. Sometimes the company is, because of lack of supply, is forced to go with slight raw materials with slightly lower technical specifications, but at a lower price. It is up to the feed mill to evaluate if it is advantageous for the company to do so. If the feed mill is will suffer, for example, in terms of operation by using those lower technical specification materials, then you have to think very closely on using those materials. Another thing is that is controllable is good anticipation of arrival schedules. If you are able to plan well, plan ahead, then your storage facilities can be planned at competitive rental rates. Okay. Number four, higher recovery rates or lower losses at the port or pickup site. Always, the evaluation of the material acquisition cost should always be a factor. That should always consider the percent recovery or the material loss from point of acquisition to the feed mill, not just the purchase price, but the recovery rates or lower losses, because somehow this can make your product uncompetitive. The next aspect would be the shipping and trucking. Which items are controllable? The fuel price, we know, may be out of the feed miller's control due to world price market movement, especially now with the Ukraine-Russia war. However, some aspects of the shipping and trucking costs can be manageable. For example, the strategic location of company-owned plants and warehouses or toll feed mills. These can be anticipated through 5-year or 10-year development master plans. For example, when the plant percent utilization will be approaching 85% in some future date, then new warehouses and feed mills would have to be available by then at the pinpointed growth areas. Otherwise, if you fail to plan or install the facilities, the business will be saddled with extra shipping and trucking costs that can become uncompetitive. Another item that is controllable is the guarantee of fast turnaround for the trucks, because this can be a leverage for lowering the cost per metric ton. Another item to be considered is the opportunity for backloading of raw materials and finished goods, which again, we can have an opportunity for lowering the total shipping and trucking costs. For warehousing and storage, the land itself, the storage area that we have may be limited due to space constraints. But some aspects, for example, of company-owned warehouse and storage facilities can be manageable. For example, if we can optimize the balance between the bulk and the bag format for both raw materials and finished feeds, then it's up to the feed mill to plan what percentage of materials it thinks will be stored in bulk form and how much will be stored in bags. Another thing is the correct planning of efficient material movement. So from raw material acceptance to finished feeds loadout within the feed mill plan. The third thing is the maximizing our mechanization versus manual labor for all logistics movements. Manual labor is, in the end, more costly for a feed mill. So for those who can afford this, or their volumes can justify this, maybe they could consider the robotic palletizing or conveyorized finished goods loading to trucks, or palletized loading to trucks for deliveries of a few feed types. This is an example of an efficient material flow from raw materials to finished goods in a feed mill plant. This can contribute to the lowering of costs even during times of high fuel prices and high labor costs. Also, it can contribute to lower forklift-related costs and lower conveying costs. So in this layout, we can see that from outside, the truck will be first going to the truck scale, and then if it is a grain, they can deliver it to the grain silos or flat box storage for soya, or for liquids, they could deliver just unload it to the day tanks, and then if it is in bag form, they could go to the raw materials warehouse at the back. Okay, after unloading, the truck can go again in the front, the truck sale for the tailway. So inside the feed mill, the movement would be from the raw material warehouse to the feeds processing to the finished goods warehouse in front. So this one is an example of a very efficient goods movement, trucks and goods movement inside a feed mill. When the feed mill has an inefficient flow resulting in loading and loading delays, truckers will not prioritize you, or the trucking rates will be higher than efficient competitors. So this is one very critical factor in times of trucking shortage, especially now when trucks can shift easily from one industry to another, from feed to food to construction industry. For rented warehouse or storage, again, the storage area may be limited just due to space constraints, but you can still optimize your rented warehouse operations by investing in pallets, for example. It can increase the utilization from 1 metric ton per square meter to as much as 1.6 metric ton per square meter. Okay. Or another thing is considering the use of 1-tonner bags instead of 50-kilogram bags for raw material storage. Now we go to the feed manufacturing. What costs are controllable in the feed manufacturing? From experience, I would say that the feed mill design would be a very critical aspect, not only because it is my forte, but I've seen a lot of ill-designed feed mill plants which had suffered through the years. Okay, although the feed manufacturing cost, if you saw in the table a while ago, the manufacturing costs actually account for the smallest percentage among the feed cost components. But from my experience, a poorly conceived feed mill could easily double the operating costs when the efficiency drops to around 40 to 50%, which is in reality, it happens in a lot of feed mills. The And the problem with when operating a feed mill is with this ill design is you cannot afford to stop it once you start operating it. So you cannot afford to stop it just to make some rectifications or no modifications in the process. So in the end, you have to live with that poorly conceived feed mill for the next 20 years. Another thing, the other aspects that are controllable will be the capacity planning. So it takes anywhere between 18 to 30 months to build a plant from the greenfield. And just like in the warehouse, when the plant utilization is perceived to be approaching 85% in some future date, then you have to build the feed mill. You have to start planning building the feed mill with an 18 to 30-month lead time. Because if you do not, then the business will be saddled with extra manufacturing and shipping costs that can become competitive. And in the worst case is poor capacity planning can allow competitors to gain a foothold on one's dominant sector. So, for example, these are a good feed mill design could translate or should translate to a sustainable lower variable and fixed cost. So for example, in the raw material processing, you have to decide your optimal number of dosing silos, the floor area of the raw material warehouse, whether you want 15 to 30 days usage or storage, the number of grain silos or bulk storage floor area, the acceptance sampling area for bulk and liquid raw materials, the number and the capacity of the truck scales, the number of intake and putting areas, the number and capacity of forklifts. And for the batching, pelleting, and bagging line, you have to decide whether you want post-grind or pre-grind, the mixer type and capacity, and the number of liquids to the mixer, the number of pelleting lines, the quality sampling points along the process line, the number and capacity of weighers, the reprocessing points, the post-pellet liquid addition, for example, the fats coating or liquid enzymes. For the finished goods storage and distribution, you have to design the number of bagging lines, the number and capacity of bulk silos, the floor area of the finished goods warehouse that you want to allot, whether it's 5 to 10 days usage, the number and capacity of forklifts, the number and height of loading bays, and palletized loading and manual loading capacities. So this should translate to the lower variable operating cost components such as direct labor, direct power, direct fuel, and direct manufacturing supplies, and also lower fixed operating cost components like indirect labor, repairs and maintenance, depreciation, administrative overhead, and interest expense and cost of money. So this is an example of material flow to a feed processing area or the machine tower. So a sample bin block, for example, of a 30 ton per hour feed mill in plan view. So at the left side, the arrow will become, this is from the raw material intake pits. So it's filling in the macro material bins and the micro material bins also. So under the macro material bins, which is 13 number, with a total volume of, which can accommodate, for example, 500 metric tons, good for 16 hours for a 30 metric ton operation. So some are doing 16 hours or if they can afford it, but the normal number of bins would be around 6 to 8 hours operation time. So under the bin would be the weighers and then the mixer area, forward to the mixing area. And then from the mixer area, you either go to the pre-pelleting area. So you have 8 pelleting bins, for example, which can accommodate 110 metric tons or 3.5 hours of operation at 30 tons per hour. So that would be a good size capacity for pelleting bins. And then for the finished goods bins, for example, you can allot 150 metric tons of good for 5 hours operation, and then on to the finished goods warehouse. So this one is an example again of some of the activities involved in feed mill construction from greenfield. So it takes around 24 to 30 months depending on how fast you can process your premise, the ECC, the pre-engineering, and the detailed plans. So what are some aspects of the distribution cost that we can control? Again, as similar to the shipping and trucking, the fuel price may be out of our hands. But some aspects similar to the shipping and trucking are controllable. For example, the location, the guarantee of fast turnaround, and opportunities. For distribution, uh, one controllable cost is limiting the number of drops per load by bundling. Here, sales personnel would have a bigger say in how this could be executed to attain savings for the company. Right now, it can be easier to accomplish using information technology. What would be, aside from these costs, what would be the emerging trends in feed milling that will impact our competitiveness in the next 2 to 5 years? I perceive that the degree of customization will increase rapidly due to many entrants with strong capabilities. And these new entrants bring with them new technologies that make them more competitive. And the trend now is for example, new farm customer having a separate feed formulation which changes every week. So this would put more pressure into the feed mill in terms of change over time, increasing the change over time. Number three, if the farm customers cannot get the desired customization parameters from commercial feed millers, they will build their own, further putting pressure on the existing feed millers with oat mills. So another emerging trend would be the drive for lower direct material costs to match ASEAN regional meat costs. So we foresee a paradigm shift from the present farmer middleman user arrangement in terms of farming to the corporate farming approach. Now, this is to better control, offers better control of crop from seed for post-harvest and the economies of scale. So we foresee companies, feed mill companies, renting vast tracts of contiguous land like the Del Monte model for planting corn. This could also tighten control of the logistics chain to reduce the transport inefficiencies. Using, for example, information technology to pursue time of demand deliveries with your suppliers. And trend towards more bulk deliveries for both finished goods and raw materials. Another trend which is now have arrived is the optimizing information technology to bring down the feeds conversion ratio and increase the average daily gain of farm animals, thus to target meat quality. Information infrastructures are being geared towards linking the dressing and slaughter plants to the animal farm and eventually to the feed mill. So the information analysis would be the key to be able to immediately adjust feed specifications based on the data from the dressing and slaughter planted animal farm. So more and more, the delay in terms of the information passing on from the farm or the slaughter plant to the farm to the feed mill is shrinking. And as it shrinks, then the more efficiency we can get. Another thing which we have to really consider is the environmental issues. Okay, so we know that the Kyoto Protocol mandated the reduction of greenhouse gases. So this one would be in the future the use of more digestible raw materials, reduce the amount of solid waste generated by the animals, and the use of better enzymes and probiotics to improve digestibility, lessen waste generation, improve feeds conversion ratio. So this one, in terms of impact to the feed mill, would be requiring good post-pelleting addition systems, okay, to break down minerals, for example, like phytase injection systems. So as my last slide, I would like to leave you with this. What every feed miller right now should ask this question: what business are we really in? So this one is a question posed a long time ago by Theodore Levitt, an editor of the Harvard Business Review, in an article he wrote in the 1960s. So he cited as a classic example the railroad industry, which was unwilling at the time to recognize that they were in the transportation business. This failure resulted in their demise. They should have adopted, according to Levitt, the moving goods as their customer-oriented business proposition, rather than sticking to the narrow notion of railroading. If they have done so, they would have created a company with systems that move goods by truck, rail, ship, airplane, or in combination, which would have helped them to transition when the railroads became obsolete. So for our business, we have to ask some of these questions like, are we in the feeds business, or in the animal nutrition business, or in the farm produce processing business? This question needs to be addressed in a deliberate manner, because we will see the trend toward specialization along the feeds value chain. And feed companies would not ask this question now and fail to plan for the next 10 to 15 years may see their position now drastically compromised. So resulting in market share reduced, profits shrinking to the point of unsustainability with the onslaught of more progressive and aggressive feed companies. So this ends my presentation. Thank you everyone for your time and attention.